Can start. All right, okay. Good morning, everyone. I'm Dr. Cuello. I'm a professor of Biosystems Engineering at the University of Arizona. And today I'm going to give a short talk on vertical farming, urban innovation toward food security, resilience, and sustainability. So today, as a planet, we're facing a grand challenge, and that is food. And it's mainly because our global population has been increasing. Currently, we're at about 7.5 billion people on the planet. And by the middle of the century in 2050, that's going to go up to about 9.5 billion. So I always say that that's tantamount to adding another China and another India to our planet in terms of population. So that's a lot of mouths to feed. And so the United Nations Food and Agricultural Organization projects that to meet the food demand by the middle of the century, we're going to have to increase our food production by 70%. And that translates into crop production of being doubled. So we have to double our crop production. But that is a very tall order because already all 70% of freshwater withdrawals goes into agriculture. And we're almost at about 50% utilization of our land for food production as well. And 30% of all of our energy expenditure goes into food production and the food supply. So if we're going to double our food production in a matter of about 2 decades or so, that really is a tall order. And so we're going to have to be innovative and create some innovative solutions so that we can actually accomplish the task of producing more food by the middle of the century. And one such innovative solution that has emerged and is still emerging is known as vertical farming. So vertical farming in essence is growing food in a closed environment system like a warehouse. And inside you have these stacks, vertically stacked shelves wherein you're growing the crops. And this is without any soil. The nutrients are delivered using hydroponic nutrient solution. And by the way, this method of production is known as hydroponics. And some are also using aeroponics, where the nutrient solution is sprayed to the root zone of the crops. But in essence, you try to control and regulate the most important environmental factors in this production system, such as the light intensity, the wavelength or the color of the light, as well as the photoperiod, the ambient temperature, the relative humidity. And the great thing about this, you don't have to use any pesticides because it's a clean operation. And you're using water as well at a very efficient rate, compared to only about you save about 80% to 90% compared with open field cultivation. So it's a sustainable method of production, and it's tightly controlled. So you're able to really maximize your productivity as well as the quality of your crops. And you're able to divorce then your crop production from geography and from climate and from weather and from seasons. So this is great. You can produce crops anywhere and anytime. And it's no surprise then that the concept of vertical farming really originated from the space program, both from NASA as well as from the Russian Space Agency starting in around 1960s or so. That is because if you're going to have a long duration manned mission on the surface of the moon or on Mars, that would be challenging because there's no available water on the surface. You have non-arable land, and you've got extreme environmental conditions, not only in terms of wild swings in temperature between night and day, but also the ionizing radiation, which is deadly to any biological entity. This ionizing radiation is bombarding constantly the surface of Mars and the moon. And so NASA then has been conducting this research and investigation on how to produce food for astronauts in space for long duration manned missions. And so I was privileged that in 1993, I had my postdoctoral fellowship at NASA Kennedy Space Center, and that was me back then, in a division called Closed Ecological Life Support System. So this is the technical term essentially for space farming. And this is an actual biomass production chamber that was used for research and experiments at NASA Kennedy Space Center at that time. So this is, imagine a cylinder that is upright and it's hermetically sealed, and the environment inside is fully controlled. Back then, light-emitting diodes were just emerging in both research and commercially, and so the light system that was used then was high-pressure sodium lamps, which you see here as this orange-hued light. But this is this is wheat. And the wheat is being grown hydroponically. And of course, it's anchored in these pipes here, which deliver the nutrient solution. And again, the temperature was controlled, the relative humidity was controlled, photo period, and all other things. So NASA has succeeded in terms of demonstrating growing all types of crops, cereals, vegetable crops, and so on and so forth, in a controlled environment system for future space applications. And this is another artist's rendition of what a human habitat on Mars may look like in the future. And of course, a part of this habitat here would be a vertical farm unit. And I continued my space-related research when I came here to the University of Arizona as a professor. And I worked specifically on hybrid solar and electric lighting systems for essentially vertical farming and space farming. Because on Mars, for instance, and on the moon, for space colony there, electricity would be very limiting. And so you don't want to use a lot of that as much as possible for crop production. But fortunately, there's still substantial amount of solar radiation that's impinging on the surface of the moon or of Mars. And the idea here is to harness that, to capture that using the solar concentrators, and then transmit them using fiber optic cables into these remotely located chambers where the crops are being grown. So back then, I was invited to go and visit a vertical farm that was just being built in Tokyo, Japan. This was in Narita. So as I was saying, the genesis really of the idea and the research on vertical farming started with NASA and with the Russian Space Agency. And Japan was the very first country really to pick up on it and to commercialize and come up with commercial versions of vertical farms. Which they refer to then as plant factories. They still refer to it as plant factories, but now it's transitioning into vertical farms in terms of terminology. So there are three paradigms of vertical farming. The first one is the warehouse, which I already referred to. And this is Professor Toyoki Kozai in Japan, and his last affiliation was with Chiba University before he retired. And he became president of the Japan Plant Factory Association as well. And he is really a big advocate of the warehouse type of vertical farm, and which is great because that is a great innovation. So here's an example of a commercial operation in Japan. It's a company called Spread that is doing warehouse type of vertical farming. So this one produces about 30,000 heads of lettuce per day. And this is the stacks, the vertically stacked shelves that they have inside the warehouse. This is another Japanese company called Mirai, and this is the picture that I showed earlier, but this is the system that they have in Japan. This one is in College Station, Texas. It's a company called iBiotherapeutic. It's also vertical farming. However, they're not producing the crops for human consumption, but those crops have been genetically engineered, excuse me, so that they produce a medicinal or pharmaceutical products such as insulin. So back to food production, this is a company, AeroFarms, it's an American company in New Jersey, and now they're expanding as well in other parts of the US as well as in the Middle East. They just established a research facility in Abu Dhabi. This is also AeroFarms. This is Bowery Farming based in New York City. All right, so that's the paradigm for the warehouse type of vertical farming. The second paradigm is the skyscraper. And this is really originated by Professor Dixon de Pommier who's retired from Columbia University. Dixon wrote a book called Vertical Farming in around 2010, and that really popularized the concept of vertical farming in North America, in Europe, as well as other parts of the world. So I credit him in terms of really globalizing the idea for vertical farming. So this is a copy of his book. So now, buildings, of course, conventional buildings being used for vertical farming is not commercially viable. And so perhaps in the future this will happen, but not yet at this time. And that was an incentive for me really to formulate a different type of building for vertical farming application, and that is the modular structure, which constitutes the third paradigm of vertical farming. And so I refer to it as the minimally structured, modular, and prefabricated vertical farm. Minimally structured, meaning reduced load-bearing requirements, reduced plumbing and electrical services, reduced materials, reduced toll weight, all this translate directly into reduced capital cost, making vertical farms more affordable and more economically feasible for vertical farming applications. Modular, this is the name of the game today for most construction. You build your modules, which are identical to one another. You can build them off-site and then just deliver them to the construction site whenever it's needed. And it translates into a cheaper operation in that way. And prefabricated as well, which is what I described earlier as well. Okay, and they can have versatile configuration. They're like Lego blocks that can be arranged in so many permutations. This is the cylinder configuration. Could be linear. You can be more fancy and come up with a pyramidal configuration. And because each of the units is standardized, so different companies then can come up with their own unique growing structures or systems that they can then fit into every one of these standardized modules. And so that allows for variety and diversity in terms of the growing system that are used inside the modular units. Okay, so, and of course, examples of vertical farming modules would be this one, which is the one that's being promoted by a company in Germany called Detail Engineering. And this is how they would interconnect those units. And of course, the most common example of a modular unit would be a standard shipping container, because they are ubiquitous and they're relatively cheap, especially the used ones. And there, in fact, there are now a number of companies worldwide that are specializing in using shipping containers as a modular unit for vertical farming. And these are just three examples. So here at the University of Arizona campus, my lab group has a shipping container that we purchased, it's used, and we basically converted it into a modular vertical farming unit. And we're using it for research as well as educational purposes. So here's the sample of what's inside. And at the same time, we've been designing original growing systems for vertical farms, one of which is the V-Hive green box. So imagine that this is occupying the entire volume of a modular unit. And so we have two boards. One is the growing board, the other one is the lighting board. Here the hydroponic units are oriented vertically, but they can be horizontal as well. And the idea here is to be able to make these lighting boards and growing boards adjustable in spacing so that you could really maximize the number of crops that you can produce in that particular modular volume. And so it's important to be able to make these adjustments in terms of the spacing between the boards, the spacing between the hydroponic or aeroponic trays, as well as being able to retract each one of these for maintenance, for planting, for harvesting, and so on and so forth. So I have a group of senior students now, interdisciplinary, and they're working on this in terms of coming up with a prototype that is fully automated. So I'm excited about that, and I'm excited to share it with the world once they're done. And they feel the same way. So this is the V-Hive green box. It's the first prototype that a group of my students built. And here is basil is being grown. Another original design that we built for vertical farming growing systems is known as the Go Vertical Farm. So basically, we have this innovative vertical farming unit that is sitting on top of a mover robot. And so then you can design then a vertical farming operation that is completely automated and using robotics. I don't have time to elucidate this or elaborate on this, but perhaps in another opportunity. So other examples of vertical farming companies, I'm including always Gotham Greens, even though really, strictly speaking, it's not a vertical farm, it's a greenhouse. But just the same, they are incorporating and employing a lot of the innovations and technologies that are now being used in vertical farming in their operations. And other vertical farms are learning from their operations as well. So this is their facility in Queens, New York, and they're specializing in greenhouses that are located on top of existing buildings. And that is Viraj Puri, is the co-founder and CEO of the company. Another company is Crop One Holdings, based in San Mateo, California. And they won this contract with a company in Dubai, Emirates Flight Catering. So the idea is to build a vertical farm close to the Dubai International Airport, which is one of the really busiest airports in the world, to produce crops that then will be used for providing catering to the airlines that are using the airport. That is Sonia Lau, who is the CEO of the company. Another company is A Essence Grows, which is based in Silicon Valley in California. And they have manufacturing facilities as well in Shanghai in China. So 2 years ago, I was invited by the company together with other experts in vertical farming for a symposium. And so we had our presentations. And after that, we were invited to join a tour of their manufacturing facility in Shanghai. And so that's where we saw these demonstrations of the various growing systems and lighting systems that the company has innovated on and has been selling. So they have these growing systems for short crops and for long crops and for vine types of crops and so on and so forth. And they have top lighting and side lighting and so on and so forth. Right. Now, speaking of China, there's another company I should mention. It's called Sanan Bio. And this was a year ago. I was brought there by my colleagues in China to their facility in China. And they have this facility that is fully automated, which is the first one in the world. And now they've released a video of it. You can check this on YouTube. I don't have the time to share it here, but they refer to it as a Sanan Bio Uplift unmanned vertical farming system. So really the development of innovation in vertical farming is going on at a accelerated pace. And so it's going to be exciting in the next few years or so. This is Norway. I'm the vice chair of the Association for Vertical Farming. This is Kristin Lossel, or Kristin Zimmerman Lossel, excuse me. And she's the chairwoman of the Association for Vertical Farming. So after our conference there, we went on a tour of a vertical farm in Oslo, which is called Tassen Microgreens, and they're specializing in producing microgreens. It's a small operation, but they plan to expand, and they're making money, so it's a feasible business for them. And by the way, this is the founder and the CEO. So how do we make vertical farms sustainable? One is by using renewable energy, definitely. So there's solar, there's wind, geothermal, and other forms of renewable energy. So here in the Southwest, we have a lot of sunshine. In the Middle East as well, there's a lot of solar irradiation that's available. And so it would make sense to harness solar energy. So one company I haven't informed you yet about is called InFarm, which is based in Berlin, but they have operations in many countries around the world now. And this is notable because 90% of the electricity used throughout the company's network is from renewable energy. and they aim to reach zero emission food production next year. So this is an excellent example of a vertical farm that's completely switching into renewable forms of energy to power their vertical farming operation. The other one is to adopt a circular economy design. So in a circular economy, you have these different components or nodes, and each component or node has an input of materials and energy, and also an output of materials and energy. So normally, if they're not interconnected, the output becomes waste products, waste materials, waste energy. So the goal is to connect them together. Of course, the nodes that you connect together must be compatible with one another so that the waste output of one becomes the input into the other node. And a good example of this would be household food wastes and vertical farms that are producing biomass waste, you know, the inedible parts of the plants. You collect them and then you put them into an anaerobic wastewater treatment plant. And that will produce natural gas with some, you know, technological processing, renewable natural gas. And this renewable natural gas would be ready for use by the vertical farms and the households. And this is not theory anymore, because in New York City, one of the treatment plants is the Newtown Creek Wastewater Treatment Plant. And they've been collecting these organic wastes from households in parts of New York, and they're adding them into the wastewater that is being processed in these egg-shaped anaerobic digesters. And the output of this, the product of this is biogas, which with further processing produces renewable natural gas. And again, that renewable natural gas is available and ready for use by households, and in theory by vertical farms as well around the world. So this is one example of a circular economy design that can be applied and adapted by vertical farms. And to end the presentation, I'm presenting Cuello's law, which is something that I initiated really as an industry goal, a goal for the vertical farming industry, and that is crop productivity per unit resource use in a tech-dense vertical farm must double every 4 to 5 years. Vertical farms benefit from the use of all of these high-tech innovations, which then translates into its dramatic increase in crop productivity and crop quality. However, it's part of the responsibility of the industry, which is to increase that productivity while at the same time minimizing the input resources. So this would be crop productivity per liter of water, per kilowatt hour of energy, per square meter of land, per kilogram nutrients, per cubic meter of volume, and per hour of labor. And again, the goal is for that productivity per unit resource use to double every 4 to 5 years. And I just want to acknowledge the bioimagineers. These are my grad students in my lab, and some visiting scientists as well. All right. And feel free to contact me via my email, and I would be happy to answer any questions you may have. But at the same time, I'm happy to answer a few questions now from our hosts. Thank you.
Thank you so much for sharing. That was great. So now we just have a few questions about your experience.
Sure.
Yeah. So what inspired you to go into this field?
Right. So I've had a long career now, but I'm not old. I'm still young. I've been at the University of Arizona now for 25 years. So I'm celebrating my silver anniversary at the University of Arizona during the year of COVID-19. But seriously speaking, what drew me to this field is sustainability, really, because I came to realize that our population is growing, so there's going to be an ever-increasing demand for food, yet at the same time, our resources are finite. The freshwater supply is finite, land is finite, and even our energy production right now is still limited. And so how then are you able to, or will you be able to increase your food production with the given finite resources that we have? So that is a question of sustainability, and it's a grand challenge that engineers and scientists really need to focus on and come up with innovative and sustainable solutions to be addressed appropriately.
Yeah, definitely. Um, what's a piece of advice you'd give to a college student looking to go into a similar field?
Right. I mean, it would help a lot if the student really has this passion and intense interest in issues of sustainability as applied to food production. Uh, that is one, because that would help them, the student, to see the big picture of what he is going into. Then, of course, it's important for the student to master the courses, you know, um, the science and the engineering and the mathematics. That's a given. But if one has this passion for this application, then that becomes easy, relatively speaking. And in addition to that, innovation is a very important thing, a very important mindset, a very important habit of mind, and a very important ability for the students now, especially in our globalized world, to really master. So what is innovation? Innovation really is value creation. So it's being able to create value using science, using technology to be able to address specific challenges and problems. That is really key. Yes.
And what look for in a job candidate?
Again, so some mastery of the necessarily knowledge skills like the science, the engineering. But then I would look really for the candidate's passion for value creation or innovation. That really is what would separate, the desirable candidates from the normal candidates. Today, in this globalized world that we're living in, where we have so many challenges, but at the same time, we have these groundbreaking technologies and innovations that are available to us: data analytics, automation, uh, artificial intelligence, just to name a few. To marshal these technologies and innovations, to be able to come up with value-based solutions to our most pressing problems, uh, that is really key. And so students really need to focus on that, regardless of the application.
Okay. And what skills have you found to be especially important throughout your career?
For me in my career. Yes. So again, mastery of the basics, that's essential. That's kind of like the foundation. But then the other thing is general curiosity to be able to understand what's happening in the world. So what is globalization? What does that really mean to be in an economically integrated global market? So that means that countries are interdependent in terms of trade, and businesses now are basically broken up into components: manufacturing, research and development, procurement. And each one of those components now is located anywhere in the world where those components can be performed in the most efficient way and the cheapest way. So if one has a good understanding of that design of companies and how business now is being conducted, that is very helpful to the student in terms of having that understanding of the world and then being able to design these value-based solutions that are needed to address our pressing challenges. So one has then gains this integrated knowledge. And when you have that integrated knowledge, then the design that you make, the solution that you offer, uh, tends to become more meaningful because it fits in that ecosystem.
And lastly, what is the most aspect of your profession?
I'm sorry, you broke up there for a second. Could you
Sorry.
repeat the question, please?
Yeah. What is the most rewarding aspect of your profession?
Oh, yes, yeah. There's so many, of course, working with the students, working with young people, being able to inspire them to innovate. That is priceless. That's number one, of course. Then being able to conduct research on these very significant areas that I'm able to contribute, not just in the general body of knowledge, but more specifically in terms of offering value to society, by which the society could benefit and grow as well. That is very rewarding. So ultimately now, what's rewarding to me is to do something, create innovation, create value that benefits society. That really is the most rewarding part of my profession. And being able to do so in cooperation and partnership with my students, that is doubly, maybe triple to the nth degree rewarding.
Great. Thank you so much for sharing. Sam, do you have any questions?
Me.
Oh, I was asking Sam.
Oh, Samantha, yeah, sorry, the reception is not so good, yes.
Can you hear me?
Yes, I can.
I just want to say thank you so much. I really didn't know anything about vertical gardening, and I didn't know that it was this big of like a project or like this many people are doing it, and it's really cool to see that it's happening. So it's really neat that you're on all these projects and like making all this happen.
Wonderful. Well, thank you. Thank you. Yes. Yeah. And that's really the reaction I usually get whenever I give a presentation, whether they're students or regular folks. They all get excited when they learn this new type of innovation. So thank you. Thank you too.